Let's look into triangle law of vector addition. The first case is adding lines which are parallel or anti-parallel. What does that mean? So let's start off with parallel. So let's take two lines. First and the second. So we have two lines which are in the same direction. The length can be anything. So the fundamental idea of triangle of vector addition is this. If you have two vectors, right, you always take either of the vectors and place it in such a way that the tail of the second vector touches the first vector's head. The order does not matter. So if I take this particular case, right, your resultant vector would be something like this. Or let me put it over here. So that would be your resultant vector. Okay, so if this is A, that's B, and that's R, this is equal to vector A plus vector B. It's as simple as that. But what if we have anti-parallel? First of all, what is anti-parallel? What do you think it is? Well, they are parallel, but there is some catch. So if this is the first vector and this is the second vector, it would be something like this. These are case of anti-parallel. So basically they are collinear lines with the direction in the opposite direction. That is, one is left, another is right, so on and so forth. Anything up, down, any angle doesn't matter. But the law holds the same, that the rule and the method holds the same. That is, touch the tail of the second vector to the head of the first vector. And now we have the resulting vector from here till this point. Okay, so this is vector M, vector N, and this is vector R. So vector N minus M. Now, when the vectors are non-parallel, then what happens? Well, the same rule holds. So we have the first vector, and you place the second vector in such a way that the tail of the second vector touches the first. And now, what is the fundamental thing that we saw over here? So whatever the first vector was, from that tail to the head of the second vector is where your result is. Just remember this. It should make sense. The tail should be at the tail of the first vector and the head should be at the head of the second vector. Same happened over here, right? You have it in writing over here. So basically, that would be a resulting vector. And again, remember, the order will not matter. Can you see that? In the first case, we added A and then B. So basically, we added B to A, and here in this the second case, we added A to B. So we can see the result is the same, right? So step 1 is to arrange the vectors. Step 2 is to join the tail of the first vector with the head of the second vector. This is the funda. Okay. So we have the example. So A and B, and that's your resultant R. Sorry, A and M and A, and still the result is the same. Okay. So you can pause and copy it off.